Let's look at some examples of confusion matrix to make it more concrete. We'll start with binary class. In this example, we are going to look at whether an email is a spam email or not spam. So spam is going to be positive and not spam is going to be negative. Now, the confusion matrix for this scenario would look like this. On the y-axis, we have predicted values which are not spam and spam. And on the x-axis, we have actual values which are again spam and not spam. So the confusion matrix itself is going to have 4 quadrants and they'll be true positive, false negative and true negative. Now, if you want to put some numbers to this, let's assume that we have 100 emails and out of those 100, 50 of them are spam and 50 of them are not spam. So that is the actual value. And if our prediction has come up with different values, then that confusion matrix would look like this. Here, we have 40 emails which are actually spam or in fact predicted as spam. But 10 emails which are actually spam or predicted as not spam. And similarly, 45 emails which are actually not spam or in fact predicted as not spam. But 5 emails which are not spam or falsely predicted as spam. Okay. So this is an example of confusion matrix in this particular example. Now let's move on to 3 class example. Whenever we have 3 or more classes, then this is the standard way to represent that in the confusion matrix. So we'll have predicted values on one of the axes. In this case, we have them in the y-axis. And the actual value on the other axis, in this case we have them in the x-axis. Then we will specify the values like this. Okay, so we'll say the first quadrant here is going to be the case where actual is A and also our prediction is also A. Okay, and on here actual is B and our prediction is A. So that is what we represent here. So the first value here is going to be the actual classification. And the second value here is going to be the predicted classification. So this way we'll populate this table for all the combinations. Okay, so this is how confusion matrix for classes that are more than 2 would appear. Okay, now if we put numbers to this, this is how it will look like. Okay, so if we take the first one as an example, this is an example where we have 30 instances where actual class is A and our model also predicted that as A. And we have 8 examples where we have the actual classification as B, but our model has predicted them as A, and so on. So this is how it works. Okay. Now, when we have more than 2 classes, we'll have the table like this, right? How do we map these to the terminology that we were seeing previously, which is true positive, true negative, false positive and false negative. Remember, these terminologies are important later on when we were deriving metrics from this confusion matrix. Okay, so somehow we need to translate these values into these terminology. Okay, so we need to have true positive, true negative, false positive and false negative. So how do we map this? Right, so the trick for that is to think in terms of one versus the rest. Okay, so rather than just looking at all the classes that we have, we're just going to pick one class and then we are going to treat all the others as rest. So that way it will be like a binary classification, right? So we're just picking one class and anything that is not that class is the other option. So this way we have simplified our multi-class classification into a series of binary classifications. Okay, so let's look at an example to make this more concrete. Let's start with class A. We are going to pick class A first. So class A is going to be our positive scenario. So the way we need to look at is class A versus not class A. So we're going to take class A and anything that is not class A is going to be the other side, which is going to be B and C in our example, right? So now if you look at the true positive for classification A is basically this one, which is the first quadrant here, because here the predicted classification is A and the actual classification is also A. Okay, so this is the true positive for our class A. Next one is false positive. So false positive is where we have falsely predicted something as A. Okay. So it is actually not A, but we have predicted that as A. What are those? So we have predicted all the values in this row as A, and the first one is true positive. So if we ignore that, then these two, which is basically B and C. So the actual values are B and C, but we have predicted them as A. And similarly, false negative. So we have falsely predicted something as not A, but in fact it is A. So those are these two, right? The actual value for these two are A, but we have predicted them as either B or C. So we have incorrectly predicted them. So we have falsely predicted them as negative. So that is why this is false negative. And the final one is true negative. Okay, true negative is little bit confusing if you don't pay attention. We are looking at A versus not A. Okay, so anything that involves A. So this involves A, this involves A, this involves A, this and this also involves A. Anything that involves A is not going to be part of true negative because we are looking at A versus not A. Okay, so all the others, so these four are going to be true negative. Okay, so the reason is, let's take this as an example. So we have classification. B is predicted as B. Okay, so now we are looking at A versus not A. Our actual value is not A and the prediction is also not A, because both of them are B, right, which is not A. So our actual value is not A and our prediction is also not A. So which is true negative. Okay, and if we take this as an example, our actual value is C and we have predicted them as B. So C is not A and B is also not A, right? So because of that, this is also true negative. We have truly predicted the negative, which is not A in this example. I know this is a little bit confusing because we need to change our mental model here. We are looking at A versus not A. Okay, so anything which is not A is going to be the negative scenario. Okay, so that includes B and C. If you pay a little bit attention, you'll be able to get it. Okay, so that is for class A. Now let's see one more example. This time we'll pick class B. So class B is going to be our positive scenario. So now the way we need to look at this, B versus not B. On one side we have B and on the other side we have anything which is not B. Okay, so now our true positive is going to be this one, right? Because our actual value is true and we have also predicted them as B. Okay, so this is why this is actually true positive for B. Now the next one is false positive. False positive is where we have incorrectly predicted something as B, but in fact it is not B. So that includes these two, right? So the actual value for these two are not B. So for this one it is A and for this one it is C, but we have predicted them as B. So that is why we have them in the false positive. And then for false negative, we have falsely predicted something as not B. Okay, so that includes this one and this one, because the actual values are B in these two examples, but we have predicted them as not B. In this example, we have predicted them as A, and in this example, we have predicted them as C. Okay, so that is why this is false negative. And finally, for true negative, anything that doesn't involve B. Okay, so if you see here, anything which doesn't have B in it are all part of true negative, because the way we need to look at them is B versus not B. We are going to look at B versus not B. So if you take the example again where we have this classification where A is correctly classified as A is not B, which is actually the actual value, and it was predicted as A, which is also not B. And because it has correctly predicted the negative scenario, so remember here, B is the positive scenario, not B is the negative scenario. So we have correctly predicted not B as not B. Okay, so that is why this is called true negative. Okay, I know the true negative scenario is a little bit harder to grasp, but if you put your head into it, you'll be able to get it. Okay, so that is all I wanted to talk about in this video. I hope this is useful. Thank you.